as we look at an angle, and we've drawn what is approximately the bisector, I know that it would do this. What about with relation to these sides? Any thoughts? Like if I wanted to know the distance from this to this, would it be this line right here? Would it be like that goofy one? How would we measure distance? So that would be straight, wouldn't it? Like that's a straight line, but that's a wonky one. Is that how we should measure the distance between blue line and purple line? Does that feel weird to you guys? What can I do to make it better? So I'm not even worried about a formula. Like just right now, like I could measure that line, but I don't think that any of us, and maybe we would, if I said, hey, the blue side of the angle is 2.2 centimeters from the bisector, does that feel like a good measurement? So I see yes and no. Like I can give you a number, so maybe that feels good. But we've made the comment before, it's been a while. How do we measure? Starts with a P. One more time, Ray. We measure perpendicularly. Love it. Good call, Ray. Okay, now I don't really care what we're perpendicular to as long as we're consistent. So I'm just going to pick a nice point because you guys can see my scale. If I measure perpendicularly, and I'm trying my best right now, it's not going to be perfect. Do you agree that that's pretty close to a right angle? Right here. And furthermore, that's 1 centimeter on mine. Everybody agree with that? Now, if I did this perpendicularly to this, what if I drew it from the other side? Is there going to be another spot that's 1 centimeter away and still forms a right angle? And notice, it's right there, isn't it? Okay, so just by drawing these, here's one set of perpendiculars that could have worked. If I did it here, would I get the same? Like those are the same, right? They have to be. If I did it here, and I'm just eyeballing it, would these be the same? No matter where I do this, should they be the same? Okay, everybody's okay with that. And whether or not that's really true, I think that it's at least believable when I draw it. Agree? Okay, now the other one, just to be very clear, and I'll just switch color, I could have measured slightly different. If instead, and I'm just going to have it starting in the middle just so I can line up this line, if I look at this one, and I'm just going to go out here, and we'll actually come down to here, and it's not going to be nice, not perfect anyway, and I'm looking for centimeters, sorry. If I do, and I'll even make it bigger, if I do this one, do you agree that that's still a right angle? But what's changed? Because Lily's mind went weird for 1 minute, and I'm cool with it because that's what my goal was. Why can I still claim it's a right angle? Because obviously not a right angle, right? Is that a right angle, though? So as long as we're going perpendicularly to one of them, we should be okay. Okay. Now, if I did that one, and that was 1.5 centimeters, is it 1.5 centimeters to the other side also? And I'll do it over here so we can see it. Gosh, it sure is. Same distance. So no matter what, as long as they're perpendicular, I get that relationship, it seems. Okay, so right now we know then that the bisector should be the same distance from both. Reasonably assume that. Everybody cool with that idea? I'm going to redraw the angle then, and it doesn't even have to be that angle to work with any of them. I'm just going to redraw an angle. And now we need to start thinking about this. Okay, if I want it to be equidistant, that's my only goal. I just need to pick, like right now, is this distance the same as this distance? Can you convince me that? You need me or you're just observing? Big Drew. She don't mean Dallas. All right. Nobody gets that joke. Maybe Lily, because Lily always gets my music references. Do you understand the joke I just made? I think it's George Strait. Okay. Well, I'm going to explain it. It's not going to be funny. So I'm going through the big. Do you know mean Dallas? I think it's George Strait. I'm not talking about Big John. I'm more of a Little John guy. Anyway, convince me. Why are those the same? If this really is the angle bisector, why would these two distances be the same?
Wait, no. Well, you could just prove the triangle is
Yeah, I see it's a hypotenuse leg. And they would be congruent, so the distances would have to be the same. So wherever I draw my segments to check my distance, quote unquote, it better be the same distance away. Does that make sense? If this point is where I was drawing it, I better make sure it's the same distance over here. And I'm going to be very obnoxious with this for a second.
Mr. Needs me to head to the tech room real quick.
Okay, bring back $50. Okay, as I'm looking at it, just with my fingers, if I did this, do I keep that distance the same? Now, I'm doing it in an obnoxious way right now. I happen to have the thing that I'm going to use. I don't know why I did that way. If I wanted the points to be the same distance, and I want you guys to do this with me, could I just do this and say, look, now we have two distances between this point and this point and this point that are all the same. Like, we just hit this part of it is what we just verified was the same. We cool. I'm cool. Are you cool? Okay. Now, the only other thing that we need is somewhere on this line is where my bisector actually lives. Now, I don't want to just eyeball the middle. I don't think that's a good idea. But if I wanted to, could we find a midpoint of a segment? Do we know how to do that with this? Just to be very clear, we do, because that's what we did yesterday. We found the midpoint. Okay, now, if I want to see it, and I wouldn't encourage you to do this, but just so you can see it's exactly what we did yesterday, I'm going to sketch a segment here. I would not sketch the segment if I were you. I'm just thinking about it. How do you find the midpoint of this segment with this guy? How did we do it yesterday? Anybody but Lily or Ray, only because they both spoke today. Check your stuff. I bet you can see it in your notes if you just look from yesterday. How do we find the midpoint? So you want me to set it to the length of that? Okay. So I'm only going to do a part of the circle, but I think it's right here, right? So we'll just go here. I'm trying to do it without moving anything. Okay, so there it is. And I'm going to adjust my piece so it doesn't try to tilt on me. Okay, so I have it set and it's there. Okay, I'm fine with that. If I go to the other side and I don't change it, it's there. And how on earth, like I could have done the same thing down here, right? And I want to notice something. And I'm going to change my setting just a little bit. If I change my setting to this wide and I make it so that it's that, here it is. And it happens to cross over right there, right? Now I haven't picked it up, but if I do the exact same marks up here, and I'm doing them very light so I don't move stuff, do I get the same direction? What points could I possibly connect at this? I need to draw from here to either here or here, right? There's my two intersections. And coincidentally, maybe it doesn't really matter because check it out. They're on the same line. And both of those intersections happened to be there. Now, by doing this, we have just guaranteed this distance and this distance are the same. More than that, we get a perpendicular bisector through it, which means these are all right angles. Are these two triangles congruent? This angle or this triangle and this one by hypotenuse leg, right? And then all of a sudden, if those are congruent, are these angles congruent? And if those angles are congruent, this purple line then did what to that larger angle? It was bisected. This is how the Greeks were thinking about this stuff 3,000 years ago. And that's awesome that we can do the exact same thing today. This was a huge discovery. You cannot trisect an angle. Can't do it. Like physically cannot cut this angle into thirds. I can cut it into fourths or eighths, sixteenths. Can't do it into thirds. Not with these tools. Okay. This stuff, it's weird, but we spent a little bit more time today thinking backward from it. Does it feel better when we thought backward and try to see are there relationships that we can use? Did that make it easier for you, Ashley? Like legitimately, or are you just saying yes because you think that's what I want to hear? Like the very last part? Okay, so just to make sure we have it, you guys don't have to draw it again. I'm going to do the exact same thing, but I'm going to do way less writing. Okay, if I want to bisect this angle, And one more time, just to make sure we're all on the same page. Don't care where it's set. I'm just going to set it. I just picked it up at this length. I draw that. That's step one. Okay, now for this next one, I don't even have to change my compass. I can if I want to, but I don't have to. There's an invisible segment here. I put the pin down right there, and I'm just going to draw out to get a mark. I'm not going to change my compass. I'm going to draw out to get my other mark. I'm just going to put it on the other pin, and notice it crosses. And I can see where it crossed, and I was really lucky. And now all I have to do is just there. That's it. Sorry. Cool. Yep, we are done with it. Now, did that feel like a proof? Was it? We literally just proved it. We didn't write it anywhere, but we did talk it because we talked about hypotenuse leg, congruence. We just didn't write everything down, but we just did the proof without formally writing it down. Now, the cool part is that we can simply assume that what we draw is a bisector as long as we treat it with some special stuff. So with that said, I'll have you guys put your bell ringers away. Yesterday, we were doing this stuff. Homework due today or due tomorrow? Did we talk about it? Okay. Do you want to check the first few problems from yesterday? Did anybody do the first few problems from yesterday? Okay. We'll check them all tomorrow. If you've started, awesome. If you haven't, that's fine. It's less awesome. Be aware that tonight's probably going to be more homeworky if you didn't do any of it. Okay. So looking at today's stuff, I need to not sit down because I just feel lazy. All right. Here we go. Yesterday we were talking about these things. And real quickly, Raylene, you don't have to write this, but I need you to read it. What did I just write? Perpendicular bisectors. Okay, that's what we were doing yesterday, right? If you give me one segment, which maybe could be a side of a triangle is where we're going with this, the perpendicular bisector can be drawn. Now, what are some things nice about the perpendicular bisector? A point is on the perpendicular bisector if and only if what is true? Use different language. I like the equa part. I don't like the valent. Equidistant or equidistant. I think it's equa, but equa is how it looks to me. Okay, so we had that theorem. Today, we just have the second half, and you guys will have some time in class today. And as long as you're working, I won't give you a pop quiz on bisectors. Cool. All right, first half of the section yesterday was perpendicular bisectors. Today, we'll be talking about angle bisectors. Now, just to save a little bit of time, I'm actually going to call this the angle bisector theorem. Yes, miss? We are still in the same section, yes. Still 5.1. Okay, I'm just going to immediately jump in and say, hey, let's just talk about the angle bisector theorem. And then I don't normally do it this way, but so it stands out a little bit. There's a number here. I just got to see what it is. This is 5.3 and 5.4. So I'm just going to write 5.3. And just like yesterday, all that I'm doing instead of two theorems, we're just simply making it a single theorem with if and only if. So it goes both directions. Okay, first thing I'm going to do is we're going to sketch roughly, but at least kind of accurately, an angle bisector. Like we don't have to fully construct it as long as we can all say that it's not perfect, but we'll assume it is. Okay, so I'm going to sketch an angle for us to use just in our picture. And here it is. It's wonderful. And should we name it? Okay, FRE. And then I'm going to sketch the bisector, and we'll call that point D. So here's old Fred. Okay, if I want to make sure that this thing is the angle bisector, then I would have to have what marked? What do you think, Vincent? Right now, I have no reason to think that this is a bisector. What would I have to mark to know that this angle was cut exactly in half? The little arc, right? Okay, so I'm going to put an arc on each of these just to like look at it and say, hey, this is. So here we go. So we have an angle bisector in front of us at this point. Now, here's our singular theorem. We're going to make a claim. A point, any point, but a point in general, is on the angle bisector, and we'll just write it with our shorthand, BIS apostrophe R, if and only if. Now, we actually used this during our construction earlier when we said, hey, if I tried to measure this distance, if I were to measure the distance from this to this, is it the same as this to this? And let me rephrase. If I were to measure the distance, and I'm going to do it perpendicular from this one since I didn't mark out my points. If it's purple right now, we don't need to. Could I measure the distance here and it'd be perpendicular? And I could measure the distance, and I'm going to switch color just so it stands out. Could I measure the distance here and be perpendicular to that also? What's true about these two segments then? They're equal, right? Which means if this point is indeed on the angle bisector, which it is, I can see that it is because we drew the angle bisector. If the point is on the angle bisector, then it's what from each side of the angle? What's the word we used yesterday? Equidistant. These are my sides of the angle. Is it the same distance from both sides? Boom. If and only if it is equidistant from the sides of the angle. Okay. Now, in this picture, very specifically, I'm going to use this just as an EG. So here's an example of it, but I want to really stress, and I know that we stress this every time. I'm going to stress it some more. If and only if means it goes both ways. If it's on the bisector, then it's equidistant. And if it's equidistant, then it must be the bisector. Okay. Now, I didn't mention it here, but how do we always measure distance? Let me rephrase. Not a number. If I'm going to measure distance, I have to do it in some specific way. Starts with a P, ends with an perpendicularly. Perpendicularly. Awesome. Okay. I didn't state it, but real quickly, this is lame, and I hate it when people do it to me, but there's times where it's effective. How do we measure distance, everybody? So that was about 60. How do we measure distance? How do we measure distance? There it is. Cool. You can feel me staring at you. Vincent, I didn't hear you yet. How do we measure? Oh, wait, hold on. Did I tell you guys I was going to mess with you today, or is that a different class? Okay. So here's one of my favorite things to do. Vincent, how do we measure? Go ahead, Vincent. What's a word I've made you say like 5 times now? Perpendicularly. Love it. Okay. So check it out. On this picture, we're just going to have a quick EG. Now, I already have it marked, but we're going to make 2 things. If RD, that segment or ray, how would I draw a ray? So how do I make this a ray? Because right now it's a segment. There would be an arrow, right? Okay, I'll just use a segment. If RD is angle bisector, then, and I'm going to have to name a couple of these points. Fred, I don't have 2 letters to make it a new name. We'll call it A and B here. There's no good way to talk about it. What would be true about CA and CB on my picture? I added A, B, and C. If it is the bisector, then what's true about these segments? Equidistant, which means they're the same length, right? And a better way to say they're the same length is that the segments are congruent. AC would be the same thing as BC. Now, up to you guys. We can write the converse of this, though. And a follow-up question, what is a converse other than some shoes? What's the converse of this statement? If I give you a hint, it's going to be obvious. If I tell you if P then Q, can you change the order to give me the converse? No. What is the new order, Camille? If Q then P. We just switched the order, right? So switch this around. If AC is congruent to BC in this picture, then RD must have been the what? So careful, we're reading the converse. We're gonna try again. If, well, I'm gonna label this so it's a little bit easier to see. And remember, please tell me if I'm going too slow, right? Like, because I can't tell if when I ask a question, if people don't answer it, I don't know if it's because you're bored, which how could you be bored in a math class, first of all? Okay, don't answer that. But I can't tell if it's because you're bored or if it's because nobody knows. And there's a big distinction. If it's bored, whatever, that sucks for you, I guess. I'm not bored. But it's because you don't know. That sucks for everybody, me included. If P, then Q. What's its converse? It says if Q, then P. So what would that read? If, and it's up to you if you needed to write this. I didn't think we did, but I don't know. What's the converse then? If, good, if AC is congruent to BC in this picture, weird, then what do we conclude? RD angle bisector. Okay, this is all that I mean. This is the original, and this is just a review of old stuff, but that's worth doing because cumulative exams and such. And this is the converse. These are the two statements that we get from it. Okay, the good news is that took a little bit longer to do. We're going to do one problem together. That's it. Like we only have one more to do. So, questions regarding this theorem before we just jump right to an example? Okay, so here we go. Example, I want you guys to use angle bisectors in some fashion. Random question. Anybody in woodshop? Have you guys made projects yet?
Oh yeah, we made a bunch already.
Do you guys want to make some sweet decorations for my classroom? We can do the woodshop. I'll talk to Jeffrey if you guys want to go work in the woodshop. We could probably just do it with like some sweet paper and stuff. We're gonna do it with paper. That's easier. You're gonna help me decorate my kid's room or my classroom. I don't know. We'll decide. Cool. All right. So let's check this out. I'm gonna sketch a picture here that we're gonna use for both of them. I'm just not gonna label anything on it, so it looks like a problem from your homework. So here's a big angle. Fantastic. And I'm gonna draw what I assume is the bisector, but I have no reason to truly believe it. Okay. And we're gonna call this H on the top left. I'm gonna put a point here, and I wish that I'd done this better, but that's okay. H, G on the bottom, and you guys help me eyeball. I need this to be the same distance. So I'm imagining like a circle here. Do you agree like here-ish is about the same distance from G? And it's actually probably about exactly that, but that's okay. J, and we're gonna call a point here where I'm gonna sketch these bad boys perpendicularly, and it's clearly not a true bisector because things feel wonky, but I'm going to label this point delta. I lied. I. Okay, real quick, just random thing, not math related. Ashley, NATO phonetic, which is the words that I use for these, give me any of them. There's 4 to pick from. Do you remember G, H, I, or J in our phonetic letters? A is alpha, B is Bravo. Do you remember any of these? Okay, so I'm going to make you guess one, and here's your hint. Which one is golf? G is golf. Raylene, give me another one. I don't like to stay at motels, but I don't mind staying at... Drew, give me another one. I thought you were going to give me a different one. Hotel, H. Golf, hotel. I would like to visit this country, but I'm afraid of the pollution. That's not a very nice thing to say. There's a lot of really natural beauty here. It's India. It is India. I don't think this is a controversial statement. One of the most polluted countries on the planet. Makes sense. It's not a very, it's like land-wise, it's not huge, and there's 1 billion people. Like, of course, it's going to be kind of dirty from time to time. And J, not Jomeo. All right, Juliet. Cool. Not our focus. Here's our problem, though. On A, Now, if you want to draw it twice, you can. I've given you a picture. I'm making it very much like the book problem, just so you guys are aware. Okay, I want you guys to do the following. You are going to be, for this picture, you are going to find the measure of angle India, Golf, Juliet. India, Golf, Juliet. If, and I'm going to give you some info. I'm going to tell you that HI is 7. And beyond that, IJ is 7. And the measure of angle Hotel Golf India is equal to a cool 25 degrees. Okay, I give you some information. Now, unfortunately, you guys just all have to be jealous because you can't do this. I'm just going to do it twice so I can draw on mine. I don't really mind if you draw on yours once because I'm going to give you another one here in a second. You don't really truly have to draw 2 of them, but we need to make a decision. Is this a together problem or is this a you guys try it talking with yourselves together? Whole class or small group? Small group, I'm fine with. Here's the deal. I'm going to give you like 2 minutes. I want you to solve this problem. If you can't, and you don't know how, and your neighbor doesn't know how on earth are you going to solve this still?
So it's a proof, right?
It is not a proof. So just to be very clear, because it looks kind of like it if with the if stuff, right? There's a key 2 things that you're going to say. If it's a proof, it's either going to be show or prove. You will see one of these. It'll say show this statement or prove this statement. If that's not in it, it's not a proof. Okay, 2 minutes. If you don't know what to do and you guys can't figure it out with you and your neighbor, who's got 2 thumbs, is super cool and willing to help? This guy. All right, cool. Do it to it, 2 minutes. I'll get B written out as well, and then I'll find this random thing that I've been thinking about since I wrote it with the theorem stuff. Cool. Work it out. Don't care if you're wrong, but try it. Bravo. And we'll talk about the logic here in just a second, just to make sure we're all on the same page. I want you to find IJ if the measure of Hotel Golf Juliet is 57 degrees. And the measure of angle India Golf Juliet is 28.5 degrees. And hi, that segment, HI, is 12.2 units, whatever they are. Okay, I'm going to give you guys a second to get this. I wish I could freeze this screen. You guys can't all see that one. You 4 probably can. Raylene, can you read that board from there? It's okay if no. You can? I don't know if I can. There's a pretty nasty glare. You can or cannot, Ray?
I can.
Okay. Well, I'll give you guys a second. Get this written down. Do you have it? So that you can give it to Drew. Because I'm going to do some Googling while you guys finish this one. So I'm going to find that Pythagorean thing. Andrew, just to check, are you actually listening or is he just talking and you're nodding?
No, I'm trying to really.
Okay, I couldn't tell.
I understand the first part. I can see how you got that for sure, but this one a little bit more because there's a lot more numbers involved now.
And that's a harder one. Okay, just to check, like these problems legitimately they probably take longer. Just to verify our logic. Here's where if you got the right answer, you clearly assumed the right thing, but you have to be really careful when you assume stuff. You guys know the old saying? What happens when you assume? So apparently I'm just gonna start swearing in here. That's where we're heading. Growing up, I heard this all the time because I make a lot of assumptions, and it's really annoying if people make assumptions and they assume wrong, and it's a bad habit of mine. When you assume something, what I was always told by my parents over and over and over is, if you assume, you make an ass out of you and me. Like, that's what I've always heard, and it happens to spell the word assume, and it's silly, and we get a little earthquake because of how hard Lily just rolled her eyes. I was recording there. We'll be okay. All right. As we look at this, you guys obviously got 25, I think, on the first one. Now, the one thing that I want to really stress that if you didn't do this, make sure that you are. If you assumed this is the angle bisector to solve your problem, cool, it was, but be very, very careful. The fact that these are the same tells me via that theorem that we just wrote down that it was the bisector. We have to verify it's the bisector before we use the theorem that they're equidistant. But once we have that it is the bisector, if HGI is 25, then this one must also be 25, right? Because the bisector. Okay, same thing here. I bet GI, and I can't even see it, but I bet it's the bisector, but we should probably verify that first. So let's see, HGJ, that's the big angle, is 57, and IGJ, I'm just going to point to this one, is 28.5. How much of the big angle is this? Half, which means if that's half and that's half, was that the bisector? And as soon as that's a bisector, if this is 12.2, then what is this? 12.2. And the theorem itself is super easy to use so long as you're certain that you have the bisector, right? Okay. Do you want a quick brain break before homework, or do you just want homework? Okay. It's going to be mathy, just so you know, just a little bit. What's the Pythagorean theorem? Okay. So we have the Pythagorean theorem, a squared plus b squared equals c squared. And this theorem works for which shape? Right, triangles specifically. So here's what I want us to think about. Now, we will eventually prove the Pythagorean theorem, and there's a lot of ways to prove it. But if this is length A, and this is B, and this is C, I'm going to write this on the inside, and C. Is there an interpretation of this with, like, if something is squared, like if this were A feet, then this says A square feet, right? What do we represent with square feet? Which quantity is that? Like, what would I, if I said, hey, I need a cup of water and I want 2 square feet, would that make sense? Probably not. If I said, cut me a piece of string that's 2 square feet long, does that make sense? Does it?
Oh,
no. No, I would say 2 feet long, right? So what is square feet representing? And that's a what? So you're right. Do we agree it's area? Like that's like, and I know that that's there. And I don't know if you've ever seen this, but here is one way to think about the Pythagorean theorem. What's the area of this box? Based on knowing that that is A. The area is A squared, right? What's the area of this box, this square? B squared. And what's the area of this square? And I gotta, it's ugly. Is that square? It doesn't look like it on mine, but I think it's just an artifact of, what's the area of that big square I just drew? C squared. So the Pythagorean theorem is literally talking about the areas that come off of this. If you were to add up the area in here and this area, it is exactly equal to this area up here, which that's what it says. Okay, is there a difference between area and volume? So this is area, right? This is no longer the Pythagorean theorem. Is it still true? Like, we can check. I know that 3, 4, 5 works for right triangles. What's 3 cubed? 27 plus what's this one? 4 cubed is 64. And if it were 5, and I'm just using a 3, 4, 5 right triangle that works, this is equal to 125? It's not, right? Do we agree that this doesn't seem to work for volume? So here's what just melts my mind. I don't know what brought this to mind. Here's a right triangle. And connected to this right triangle, they have the squares like we just drew, but it's filled with water. I cannot imagine. Oh, come on, do it. Okay. I've never really thought about the proof, like how to construct this. But they're doing the Pythagorean theorem with volume right now. And I assume that all the boxes have the same width. I have no idea what that width is. But for whatever reason, we made a comment at the start of class today that made me think of this video. It makes sense that it works with area. Like, we can see it, the Pythagorean theorem is true. We just showed that it didn't work with a volume. But when we think about how much water is in each one of those little things, it is volume, isn't it? What on earth is going on here? Can I tell you my suspicion? I think that they didn't actually do the calculation to find that one perfect value. I think instead what we see happening is underneath of this, I bet there's more tank. So that there's extra water left over. We just don't see it. Random thing, but I like this, and I wish I had one. Not what we're making. I don't know. Kind of interesting or not at all? All right, yeah, it's really interesting. We all know it. All right, so tonight, now, 10 minutes. I want you to add to your homework, and I'm going to write it on the backboard, and then I'll put up, you know what? I'm going to write it on Google Classroom, then I'll put it on the backboard. So let's see here. You have to write a 500-word essay about why I'm the coolest person you've ever met. I will check it to see if AI was, no. We could write essays in here at some point. Math papers are actually not bad to write. Depends. It'd be a historical thing. Anyway, I want you to add. So this is 12, 2. Hey, I already did it. I want you to add 11, 20, 21, 25, and 26 to last night's assignment. Okay, I will edit this one. Wrestlers, I understand you're busy. I want you to try to get this done. Nonetheless, your meet starts at what time? You can put on all your heavy clothes. Are you guys weight good? Are you heavy?
2 pounds over.
Okay, that sucks. I want it tomorrow. If you want to come work in study hall until 4:30, like, do it. I'm fine with that. I'm here.
4:30.
Or 4, whatever. If you want to come do it in study hall before your meet, and just go, like, if you want to go put on all your clothes, are you going to try to sweat out your weight? Hold on.